Okay, we are rocking and rolling now. First off, before I get started, do you guys have, you two that are in here, do you have any questions from the previous lecture? If you don't, that's fine. I'm just trying to get to see where this, not right there, okay. Okay, I mean, if you don't have any questions, I'm going to start on today's, and actually, I believe today we'll be able to get through two sections today because I don't cover the entire content in 6.3 or 6.4. So we'll get through both of these today. And they're really, in my opinion, they should have been done first. I think section 6.3 and 6.4 really should be section 6.1 and 6.2, the way your book goes over this. But I did not make the book. I did not make all the money. So let's start in 6.3. So 6.3 starts with really the matrix notation, which we've talked a little bit about already. So let's look at this notation. Hold on, my stuff all over my glasses. So let's look at a matrix. Let's define a matrix. We'll call it matrix A, and it'll be 1, 0, 9, -2, pi, and square root of 2. Why not? Okay. So we've got this matrix A, 1, 0, 9, -2, pi, square root of 2, right? There's 6 different, units or cells within this matrix. And if we want to, first we need to talk about the order, which we did in the last lecture, right? If I asked you for the order of this matrix, you tell me, okay, now remember, order is rows by columns. So this is 2 rows by 3 columns. Right? So 2 rows by 3 columns, not a big deal. But it turns out if we want to, kind of pull out a certain cell within the matrix, you can do that by using its position, actually. Let me make sure I'm doing. Here you go. Yeah, we'll call it the position. So within A, like let's say I wanted to identify this -2 here. So that position actually is always going to be row by column. So this is row 2, column 1. So I'm going to use lowercase a because it's a position within the bigger matrix. And I would say, well, position A, row 2, column 1 is -2. So A21 would be -2. Where, like, if I wanted to call, let's say, number 9 here in this matrix. So if I wanted to call number 9, it's in the first row, but it's the third column. So A first row 1, third row 3. So A13 would be 9. Okay, so those are how you could call them the positions. Those are the positions of the matrix. Okay, I'm trying to find what your book calls it. Just says identify. Yeah, we'll call it the positions. The positions in the matrix, the units in the matrix, a cell in the matrix. I'll tell you, the very bottom right position will always be just the order, right? So if I wanted to call the square root of 2 here, it's going to be, well, the second row, the third column, right? Second row, third column is just the square root of 2. Okay. And we talked a little bit about the order yesterday. And then your book goes into the equality of matrices. Well, if it turns out if 2 matrices are equal, all of their positions will be equal, right? The 2, 1, the 1, 3, the 2, 3, they're all going to be equal on both sides. So if we know that, let's say matrix A here equals matrix B, then when we write that, so 1, 0, 9, -2 pi, square root of 2, if I say, okay, well, A equals B, and then let's make up a B matrix. Let's say it's X, 0, Y plus 1, let's say -2, R let's say the absolute value of R and square root of 2. Okay? So we've got x 0, which we know 0 has to equal 0, y plus 1, negative 2, the absolute value of R, and the square root of 2, right? And so with equality, what typically comes with equality is solving for variables. We want to solve for this x, y, and the absolute value of R. So to do that, we know that their positions have to be congruent, they have to be equal. So therefore, x has to be 1, right? Because its position in both matrix has to be equal. So therefore, x has to equal 1. And then for y plus 1 over here, which is a single cell, y plus 1 has to be equal to 9. Well, that's not a big deal. If y plus 1 equals 9, we just subtract the 1, and we find out that y equals 8. Okay? Now let's solve for the r here. Well, the absolute value of r is pi. Ooh, this one's a little different because, when you take the absolute value, it makes everything positive, right? So it turns out r can be two things here, right? R can either be pi or r can be negative pi, because when you take the absolute value of negative pi, you wind up with positive pi, right? Okay. Hopefully that makes a little sense. So we actually have 4 solutions going on for this equality matrix. But I'll tell you, the kind of the intent or the purpose of going over the equality is really understanding that when you have two matrices that are equal, they have to have the same exact order, and each of their cells that corresponds to the same position has to be congruent. Like this 0 could not be 7, okay? If that 0 was 7, we would say that this was not congruent because 0 does not equal 7, okay? It has to equal 0. Now the variables are a little different because, if you're saying, well, x doesn't equal 1. Yeah, x is a variable, so x can equal 1. And for this one, x has to equal 1, right? For the way equality is set up. Okay. Questions so far? I'll tell you, this section's not that difficult. It's just new. Okay, it's not that difficult, it's just new. And you two that are in the class right now, if you have a question, just ask. Don't be afraid to chime in. Not a big deal. You're not gonna hurt my feelings. And if you don't get it, I promise someone else isn't getting it as well. Okay, so now let's start with basic arithmetic of matrices, which you could say this is basic arithmetic, knowing that two things are equal and their positions are equal. But the most basic type of arithmetic is addition or subtraction. So it turns out when you add or subtract matrices, they have to have the same order, okay? Let's make up 2 new matrices. Actually, let's make up 3. I'm going to make up 3. I'm going to say, let's see if I can write them up here. Let's say matrix A is 4, -1, 2, and 9. So a 2 by 2 matrix, right? Matrix B is going to be 1, 0, 8, 2, -3, and 4. So we got a 2 by 3 matrix, right? Matrix C is going to be -1, 9, 8, and -7. A 2 by 2. We'll throw in a third matrix. Matrix D, we'll call put a 0 in here. So no, let's do -1, 7, 5, -2, 3, and let's say -5. Why not? Okay, so I'm going to use these 4 matrices for the basic arithmetic that we're about to cover, okay? And that way we'll just keep it consistent with the matrices we're using. I don't have to make up new ones each time. Okay, so what I said though was that to add or subtract matrices, you have to have the same order, right? You have to have the same order. Oh, I feel like multiplication's next. Oh no, they do adding and subtracting. Okay. You have to have the same order. Well, only 2 of these have the same exact order. If you want to write the order down, there's nothing wrong with that. You won't get counted wrong. So if we look at A, we said this was a 2 by 2 matrix, right? 2 rows, 2 columns. B is a 2 by 3 matrix. This is a 2 by 2, C is a 2 by 2. And the matrix D actually is a 3 by 2, right? Because it's got 3 rows and 2 columns. Well, only 2 of these match, right? And for addition and subtraction, we have to have the same order. I've said that like 5 times now. So let's add A and C together. So the way you would do this is, let's do A plus C. How about that? A plus C. If we're going to add A plus C, it is exactly what you think it is, okay? When you add or subtract matrices, it creates a matrix of the same exact order of the 2 matrices that are adding and subtracting together, and you just add the positions together. I'm going to be real lazy here, okay? Efficient is what we like to say in mathematics. But if I want to add A and C, I would add, for this first position, it's going to create a 2 by 2 matrix, okay? The first position is just going to be 4 plus a -1 because they're in the same position. So that gives me 3, okay? And then I'm going to go to that 1, 2 position, -1 plus a 9. So it's going to give me 8, okay? And then I'm going to do 2 plus 8. That's going to give me 10. And then lastly, 9 plus -7, that's going to give me 2, positive 2. So therefore, we have the basic arithmetic of matrices. We just added 2 matrices together. Very straightforward. Okay, let's do subtraction and we'll flip them. We'll do C minus A. Get a little crazy here. Okay, C minus A. Okay, so if we're going to subtract, all we're going to do is do subtraction of A. So we're going to start with C, the position for C. Then we're going to subtract off whatever the position that correlates it with A. Again, it's going to make a 2 by 2 because these are 2 by 2 matrices. So let's look at C here. Now, this first position, we start with -1. We're going to subtract 4. -1 minus 4 gives me a -5, right? And then let's see here. 9 minus a -1, that's going to give me 10. 8 minus 2, that's going to give me 6. A -7 minus 9 is going to be -16. Okay, so -5, 10, 6, -16. -5, 10, 6, and -16. Great. Okay. Again, you two that are in the class right now, if something doesn't make sense, let me know. If not, I'm just going to keep rocking and rolling. So if you don't slow me down on these, I'm going to just keep kind of zooming. This, again, I hate saying this is easy because I get it. It's new, but this isn't the hardest concept we've covered in college algebra. I can factually say that. This is not the hardest concept in college algebra. Okay, so the next type of basic arithmetic is called scalar multiplication. Scalar multiplication just multiplies a number through a matrix. So I'll choose either B or D for this. Let's use D. So let's say I wanted to find 3 times D, okay, 3D. So if I want to find 3D, I just multiply 3 to every position inside matrix D, okay? So I multiply 3 inside to every position in matrix D. Very straightforward. Okay, so if I look at D over here, I'm going to multiply every position by 3 because that's the scalar number that we're multiplying by. So 3 times -1, that's going to be -3. 3 times 7, that's 21, right? 3 times 5, that's 15. 3 times -2, that's going to be -6. And 3 times 3, that's 9. And then 3 times -5, that's -15. So then we found our scalar matrix. We've just scaled up actually D by 3. Okay, that's the kind of the terminology we use there. Okay. Make sure we haven't missed anything. Yeah, I mean, it's pretty straightforward there. Let's go back to like A and C that were the same order so we can combine the scalar multiplication and basic arithmetic. So let's say we had Again, I'm going to use A and C here. So let's say we had 2A minus 3C, okay? 2A minus 3C. Well, now look, this follows basic order of operations. You're going to multiply before you do the subtraction, okay? Actually, let's make this addition just for fun. So you're going to do the multiplication before you do the addition. So first I'm going to multiply the 2 through the A. So this first matrix, 2A, would be, well, 2 times 4 is 8. 2 times -1 is -2. 2 times 2 is 4. 2 times 9 is 18, right? That's 2A, 8, -2, 4, and 19. Then I'm going to do the addition of 3C. So I'm going to multiply 3 through by C, or 3 into C. So -3, 27, 24, and -21. Okay, so -3, 27, 24, and -21. Now I just have to add them together. So now we can add these, right? Because they're 2 by 2 and 2 by 2. If it would have been 2A plus 3B, we wouldn't have been able to add them. We would have been done actually at this point. So we can add these. So this becomes 8 plus -3, so it's going to be 5. -2 plus 27, that's 25. 4 plus 24, that's 28. 18 plus a -21. Oh, I'm going to use all my fingers and toes for this one. It would be what? -3, right? -3. Okay. Boom. We are done. Okay. Questions about this one? Okay. Well, the next thing is actually combining all of this. So we're going to go into equation solving using basic arithmetic with addition, subtraction, and scalar multiplication. So I'm going to steal this one actually directly from the book so we get nice numbers. Actually, I don't even think you get nice numbers. So forget it. We're not doing that. We're going to just make one up here. We'll use 2A and C again. So let's say, oh gosh, we've got 2x minus A equals B. They do something like this. 2x minus A equals B. Now we know that, I'm sorry, we'll use C to make it the same matrix. Now we know that, we know A and C, they're right here. So what we're going to do is we're going to solve for matrix X. Now look, these all have the same order. So therefore matrix X is going to be a 2 by 2 matrix, okay? And we're going to go through the steps to do this. Now, I like plugging A and C in right off the bat. Okay, so I'm going to say 2x. Actually, yeah, I like plugging A and C. So minus, and A is going to be 4, -1, 2, and 9 equals C, which is -1, 9, 8, and -7, right? And the first thing I need to do is add this matrix over, which I think we did this at the very beginning. I should have kept those results. I'm going to add this matrix, just like if it was a number, right? So we wind up with 2x equals, and now look, I'm going to just do this right here. -1 plus 4, that's 3. 9 minus 1, that's 8. 8 plus 2, that's 10. -7 plus 9, that's going to be a positive 2. This should have been what we got at the very beginning, the very first example. This is what we got, right? Because all we're doing is adding C plus A. And now, basic arithmetic, we've got to get rid of the 2. Instead of dividing by 2, we're going to think of this as multiplying by 1/2. Okay, so I'm going to multiply both sides by 1/2. So what we have is we have scalar multiplication like we did in the last example or the example before that, okay? So we wind up with x equals 1/2 times 3, 8, 10, and 2, okay? And now all I've got to do is multiply the 1/2 through, and I've found x. So 1/2 times 3, that's 3/2. 1/2 times 8, that's 4. 1/2 times 10, and that's 5. 1/2 times 2, that's 1. boom, I have found my X matrix. So this is combining that basic arithmetic into a neat little equation, okay? And getting comfortable using the matrices with addition. Actually, this one has it all, right? This one's got equality of matrices. It's got addition of matrices. It has scalar multiplication of matrices. So everything we've gone over to this point is in this section, okay? Okay. So lastly, in this section, or what we're going to go over lastly, is matrix multiplication, okay? So matrix multiplication. So I'm still going to use these same matrices, so you can keep those there, but I'm going to go over how to multiply the actual matrices together. So not like a scalar unit, but actually two matrices being multiplied together. Now, it's a little different than the addition or subtraction. It's not that the matrices have to have the same order. That's not necessarily true. It's that the columns of the first matrix have to equal the rows of the second matrix, okay? And you don't have to memorize that. I'm going to show you a shortcut way to identify it. But it's the columns of the first have to equal the rows of the second. So let me give you one that works. Let's say we wanted, I think this one will work because this is the columns and the rows. So I think I can multiply A and B together here. A times B, okay? So I think I can multiply A and B together. So I'm gonna write this down, 4, -1, 2, and 9. I'm gonna write a little, you guys can see this. So 4, -1, 2, 9. I'm gonna multiply it by 1, 0, 8, 2, -3, and 4. Now here's the shortcut on knowing if you can multiply them together. And order matters. I mean, not just the order of the matrices, the order if it's B or A. Unlike multiplication of numbers, matrix multiplication is not commutative. A times B will not equal B times A, okay? So the order that they occur is important, and also their order is important. Gosh, that's tough when it's the same word. But I'm going to write the order underneath each one of these. So this is a 2 by 2, and this is a 2 by 3, right? This is a 2 by 2 and a 2 by 3. Well, look, if these two numbers match, we can multiply the two matrices together, and they do, right? Remember, this number is the columns of the first, and this number is the rows of the second. And if they match, then we can multiply these together, okay? Then we can multiply these together. I know that's kind of goofy, but we'll see why actually when we do this by hand, okay? We'll see why this is true. But I'm gonna multiply these together by hand for you to show you where it's coming from. So I'm gonna erase this. And this process that I'm about to do, and I'll tell you, I love doing like kind of goofy memorization tactic type stuff and or strategies. And this one, I always think of going to Sonic and getting cheese sticks and the sauce for cheese sticks. And for this one, I need 3 sauces. I'm going to use marinara because it's a classic. And then I'll use ranch, which people typically say is their second favorite for cheese sticks. But if you've never tried honey mustard for your cheese sticks, you should try it to see if you like it. In my opinion, it's very underrated for cheese stick dipping. But I need you to think about, and I'll show you why here in a second. But because what I do, actually, I kind of visually think of dunking a cheese stick into the sauce. Okay, so let's get started. And first off, I'm going to make just a solutions matrix. I'm going to make it pretty big because you'll see we'll have to do some math inside the matrix. So the first thing you do is you actually look at the first matrix and you divide them out by rows. So I'm going to group this first row together. Okay, and that's going to be my cheese stick. Okay, that's going to be my cheese stick. And what I'm going to do is actually I'm going to take that cheese stick and I'm going to dunk it into the column Actually the first column of the second matrix, okay? So I'm going to think of this cheese steak, and think if I broke it off and I dunked it into the column of that second matrix. What happens is if the numbers overlap, we're going to add or multiply them together, okay? If the numbers overlap, we're going to multiply them and then we add them, okay? So if I think of breaking this off and putting it into this column, notice the 4 and the 1 would overlap. So I'm going to say 4 times 1. And the -1 and the 2 would overlap. So I'm going to say plus -1 times 2. And that's my first position for my solution matrix, okay? For my product matrix, you can think of it like that. So 4 times 1 is 4 plus -2. So it'll wind up being 2 when we get there, okay? I'm going to make this a little wider, actually. Probably need a little more. Okay? So now, that was the marinara. Right now, I'm going to dump this same cheese stick into ranch. Okay? I'm going to take it, and then I'm going to drop it into the ranch, and we'll see the 4 is over the 0. So 4 times 0. Okay? Plus the -1 is over the -3. So I'm going to say -1 times -3. Okay? Kind of neat. And I'll tell you, this is why they had to be the same. Look, notice the rows, you've got 2 rows, I'm sorry, 2 columns of this first matrix. They've got to be equal to the 2 rows of the second matrix. They have to be overly lapping, okay? And that's what if this doesn't equal this, you wind up with numbers that don't work out. There's no overlap for a certain set of numbers. Okay, so we did marinara, we did ranch. Now let's dip it into the honey mustard. Okay, now let's dip it in the honey mustard. So if I do that, I get 4 over the 8, so I get 4 times 8, plus -1 over the 4, so -1 times 4. And look, I've got no more sauces to dunk in, right? So therefore, I'm going to stop this matrix here. I don't have any more sauces. But I have another cheese stick underneath here. So I've got to do the same process with that 2 and 9. Okay? I've got to do that same process with the 2 and 9. I'm going to take the 2 and 9 and do the same 3 really algorithm. Okay, same 3 algorithms. Okay, so just pop it in and then multiply if it overlaps, and then add them together. So let's do this. The 2 and the 9, I'm going to drop it into the marinara. The 2 and the 1 overlap. And then the 9 and the 2 overlap. Okay? The 2 and the 1 overlap, and the 9 and the 2. Now I'm going to do the same thing with the 0 and the 3. The 2 and the 0 overlap. And the 9 and the -3 overlap. Right? The 9 and the -3 overlap. And then lastly with the honey mustard. So 2 and the 8 overlap, and then the 9 and the 4 overlap. And now I've just got a whole bunch of basic math to do, okay? And I can't get any of it wrong. If you get one of these wrong, you got the wrong answer. So I've got in this first position here, look, notice this created a 2 by 3 matrix. I'm sorry, yeah, 2 by 3 matrix. Let's do the basic math here. So this would be 4 plus a -2. And this would be 0 plus 3. This is going to be 32 minus 4. And this is going to be 2 plus 18, 0 minus 27, and 16 plus 36. So this is going to be 2, 3, 28, 20, -27, and is that 52? I think so. 52. Okay, that's our product matrix. It took us a little while, and it does. It's just a long kind of a long process to do this by hand. Okay, So other than, I just need to see that another time. Do you guys have any questions? I'll leave it up there for just a minute more. And if you're watching at home, if you want to pause it, just soak it in. I understand. We're gonna do another. We're gonna choose. We're gonna do A and C next. Okay. Or what if they have the same? For A and C, it's fine that they have the same order because they're square matrices. Okay, they're square matrices. So let's look at that. Okay, so let's look at now. Let's multiply A and C together. And I'm going to give you a minute to do this by yourself. I want you to attempt this. Let's do A times C. Okay, so 4, -1, 2, and 9 times, now let's do C. -1, 9, 8, and -7. So I want you to try this one. You try this one. I'm going to give you a minute to do it. And just try your best. If you don't get it right, that's fine. That's the whole point, is just to kind of see where you're at. So try that based off of the strategy we just learned. I'll give you a minute. Okay, I'm going to start on this and see if you're still working, keep working, that's fine. But I'm going to take this first row and I'm going to dunk it into this first column here. So that's going to give me my first spot. So 4 times -1 plus -1 times 8. And then I'm going to do that again over here. So 4 times 9 plus -1 times -7. Okay. And now look, we don't have any more spots to dunk our cheese sticks. This is just a marinara ranch example. So we're going to stop. But then we got to do the same thing with this second column, this bottom column. I'm sorry, bottom row. So 2 times -1 plus 9 times 8. And then 2 times 9 plus 9 times -7. Okay, let's see what we get here. So this is going to be -4 plus -8, 36 plus 7, -2 plus 72, and then 18 minus what, 56. So we get -12, 43, 70, and 18 minus 56. Let's see here. That would be, that's what, 38 or negative 38. Okay. Hopefully that makes a little sense. And I'm telling you, if it's not making sense, you can watch this video again, watch the previous, or watch this example again, watch the previous example again. There are a ton of examples on YouTube on how to multiply two matrices together. There's a lot of resources out there for that. Okay. A lot of resources out there for that. I go over the marinara, the cheese stick example. There's just a lot of different ways to visualize it. There's also a formulaic way to do it. And I'll tell you, I've taught the formulaic way in the past, and it seems to really hinder people grasping the motions on how to solve it. It really hinders that because you get too worked up on, does A multiply by B or B divided C? It just doesn't make too much sense. Okay, so for homework in this section, and again, this is 6.3, guys. 6.3. For homework, I need you to do 1 through 30. 1 through 41. Yeah, 1 through 41 on. 1 through 41 on. 1 through 41 on. It's on page 624. It starts on page 624. It starts on page 624. Okay. And then 6.4 is not going to take long at all today. So I'm just going to tack it on at the end of this lecture. So 6.4 is over inverses of matrices. So before we really jump into the inverse of a matrix, we need to talk about what an inverse is. And we know this already from basic arithmetic. Let's go over I don't know, whatever we start with, and we'll call it the inverse. And then the identity. We'll say value. That's not the best way to put it, but we'll put value here. We're going to go value, and then we're going to go over operation. So I should put that operation, and then the inverse, and then the identity. And there's always going to be an equal sign. So let me show you what I'm talking about here. This is the beginning of 6.4 when I'm really going to show you what the inverse is. Not just for a matrix, but for everything, right? How we've defined it in the past. Let's say we had the number 5. That's our value, okay? For the operation, let's do addition. Okay, so we're going to do addition. So the inverse with addition is always just the opposite sign of the number you start with. So we started with the number 5, right? And then we want the inverse of the operation. Well, the inverse of addition, you just take the number and change the sign. So for this, it's going to be -5, okay? And then 5 plus -5 is just 0. Okay, so for addition, the additive inverse is just the opposite of our number. And the additive identity is just 0. And the reason it's 0 is because if you add 0 to anything, it does not change the number, right? 7 plus 0 is 7. -pi plus 0 is still -pi, okay? So therefore, that's considered the additive identity, okay? Therefore, it's considered the additive identity. If we looked at multiplication, let's say we use the 5 again. So 5 times. Okay. If we think of multiplication, and this is typically when the word inverse is used, typically mathematicians mean the multiplicative inverse. And the multiplicative inverse is just flipping the fraction, right? Really, this is 5/1, so it becomes 1/5. Okay, you flip the fraction. So 5 becomes 1/5. If it was like 2/3, it would become 3/2, right? You would flip the number to get the multiplicative inverse. Well, and it turns out the multiplicative identity, when you multiply 5 times 1/5, well, 1/5 of 5 is just 1. And again, for the same reason 0 was the additive identity, the multiplicative identity, when you multiply anything by 1, doesn't change anything, right? When you multiply any number by 1, it does not change anything. And we talked a little bit about inverses when we went over function inverses, actually. Let me go over here. Function inverses and compositions, right? When we took the composition, this is a little different, but when we took the composition of inverses, remember when we had f and we took the composition of the inverse function, you wound up with x. And it's because when you take the composition of any function with x, it's just the original function, right? If you take the composition of x inside of f, it's just f of x. It's the original function. Nothing changed, okay? I'm not too worried about that one. That's kind of out there a little bit. Now, the matrix, though, is the same thing. If you start with a matrix and you do a multiplication on it, so we're going to do multiplication for this. Let's stay, and your book uses A for some reason a lot with matrices, so we'll stick with A. If we have matrix A and we multiply it by its inverse, so this is going to be the notation we use, okay, a to the negative 1. It actually equals an identity matrix. We're going to call I, okay? It equals an identity matrix we call I, and that's where we're going to start today, or for this section anyway. That's where we're going to start, okay? We're going to talk about the identity matrix first. But the identity matrix is always, it's always ones and zeros with the ones diagonal. And what happens is with the identity matrix, when you multiply the identity matrix by any matrix, it doesn't change anything. So let's look at a basic example. If I gave you, let's say, 4, -1, 2, and let's use a number. Let's use 3. Okay, and we'll call this matrix A for now. Okay, we'll call it matrix A. If I multiply that by the identity, now, so the identity has to be a square matrix, first off, has to be a square matrix. And it's going to be ones and zeros, but the ones always make a diagonal. Okay, the ones make a diagonal. So for this one, the identity matrix would be 1, 0, 0, 1. Okay, 1, 0, 0, 1. So what's going to happen, and so this will be a good example of what we did before, so we'll get some more examples then on how to multiply matrices together. But what happens when you multiply these two together, it's not going to change anything, which is kind of neat. So when we go back here, like when you multiply by 1, 5 by 1, it's just still 5, right? The same thing's going to happen when you multiply by the identity. So let's do that. Again, remember the whole marinara cheese stick thing. So 4, 1, -1 times 1, 0. That gives me 4 times 1 plus -1 times 0. And then I'm going to multiply it into the next group or the next column. So it'd be 4 times 0 plus -1 times 1. And then I'm going to do the same thing down here. 2 times 1 plus 3 times 0. And then lastly, 2 times 0 plus 3 times 1. Okay? And what's neat about this, it's all ones and zeros. So if you multiply by 1, it's just what we started with. And if you multiply 0, it goes away, right? So if we look at this first group here, this first little arithmetic, 4 times 1 plus -1 times 0, well, that goes away because it's got a 0 multiplied in it. You wind up with 4. The second one here, the 0 is there, so that goes away. You wind up with -1. Hey. And then this goes away 3 times 0, so you're left with 2. This goes away, you're left with 3. Oh man, that's cool. Look, that is what we started. That was a whole bunch of work for nothing to change, right? A whole bunch of work for nothing to change. Kind of neat. Okay, pretty neat. But that's what happens with identity. So if we multiplied a bigger matrices, now I'm not going to do the math on this one, this takes a lot longer, but let's say we had matrix B. And it was, let's say 4, 1, 2, 3, -8, 7, negative pi, square root of 5, and -1. Now, this is a 3 by 3 matrix. If you want to find its identity, it's pretty straightforward, actually. It would just be ones and zeros, but now the ones are in a diagonal this way. So it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And when you do this, when you multiply these together, now I know I'm running out of space right here. But if you multiply these together, so now you have to multiply this row by this column, and then the next one, and the next one. And notice when you do that, the 4, 1, 2 multiplied by the first position, it only keeps the 4, right? When you multiply the 4, 1, 2 by the second column, it only keeps the 1. So it's keeping the position that needs to be kept. But when you do that, you wind up with the original matrix. So 4, 1, 2, 3, -8, 7, negative pi, square root of 5, and -1. Okay? You wind up with the same matrix, which is pretty cool. Now, so this is the identity matrix. Okay, that's the identity matrix. Now, that's not hard. I know that, I mean, that's arithmetic wise, that's difficult, but it's not hard to understand as a concept. The harder concept is actually finding the inverse. Okay, finding the inverse. And there's a very tough and convoluted way to find the inverse. And we're not going to go over that. We're going to use the calculator, and you might not thank me, but you should thank me for us just to use the calculator to do this instead of working it by hand. Okay. Let's look at how to do this thing by hand. Actually, not by hand, but by in the calculator. Yeah, okay. So let's look. I'm going to steal an example from the book, sort of. But I need you to take out the calculator, okay? Take out the calculator. And remember we went over how to put matrices in the calculator in the last section. I'll go over it again. But let's look at if we had this matrix, this 2 by 2 matrix. -1, 3, 2, -5. -1, 3, 2, -5. So the goal here actually is to find the inverse. We know the identity, right? 1, 0, 0, 1. We know the identity. We want to find the inverse now that makes it, when we multiply our original matrix by the inverse, we get this identity, the 1, 0 matrix, okay? So I want you to bust out the calculator, and we're going to put this matrix in 4A. So this is a 2 by 2. Remember, we need that to put it in the TI-80, whatever calculator you have. So I'm going to go to the TI-80. Remember, first, we're going to hit second, and then 2 to the -1. I'm going to write this down for you. Sorry, x to the -1, which gives you the matrix options. And you got to go over to edit, okay? And I'm going to edit matrix A for our example. So you hit enter on matrix A. And for this one, now I've got a 2 by 3 matrix still in there from the last lecture. So now I'm going to put a 2 by 2 matrix in. And then I'm going to put this matrix into my matrix A. Okay, so step 1, second matrix, go over to edit, and then let's make matrix A this matrix. Okay, -1, 3, 2, -5. Okay, so I'm going to put that in. So -1, 3, 2, -5. And then I need to go back to the original home screen. So remember, to get back home, I'm going to hit second and then quit, which is actually second, then mode, which is second quit. Okay. And that gets me back to the home screen. Okay. So once you have this, and I'll give you just a second. Once you have that in, go back to the home screen. And we're just kind of back where we started. Okay. Okay, so now once we're back to the home screen, we got to call the matrix. So to do that, we're going to hit second and that X to the -1 button to go back to the matrix screen. And look, we don't have to do anything now. Now we just need to bring matrix A in. So click on matrix A. Okay. And when you do that, it should bring matrix A back to the home screen. It'll look actually, let me put this up here, real ghetto kind of graphics. It'll look like that, right? I'm not sure if you can see it. I can't see my screen right there. But once you do that, I want you to hit that X to the -1 button. When you hit that X to the -1 button, it should look something like that. If you've got an older calculator, it'll do like the caret -1. That's okay as well. And then when you do that, hit enter. And it will give you your inverse matrix. Okay, it will give you your inverse matrix. So our inverse matrix is 5, 3, 2, 1. 5, 3, 2, 1. So that's what your screen should have on it right now. 5, 3, 2, 1. Okay. I'll give you just a minute if it's not, if you're not there yet. And what we found though is the matrix. So now what's kind of neat is if we multiply these two together, we should get the identity. Okay. So we're going to do that next just to check it. And not really to check it. It's your calculator. It's done it correctly because it's a calculator. Okay. But I wanted to show you how that happens or that it's true. So actually, this is what I'm going to do in my calculator. I'm going to bring A back up. Now remember, to bring A, you just hit second X to the -1 and then hit enter. And it'll bring A on the home screen, okay? And then I'm going to do times, hit the times button. And then I'm going to do the same thing. I'm going to call A back up, but then I'm going to click that X to the -1 button. So I'm going to call A back up, second X to the -1, call A back up, and then hit that X to the -1 button. So I'm doing this part again, okay? And then I'm going to hit enter. And what happens is you wind up with the identity matrix for 2x2 matrices, okay? You end up with the identity matrix for 2x2 matrices. Pretty cool. I know. You don't have to tell me. And if you want to see how to do this by hand, it's on page 630, and it takes up all of page 630 to do that by hand. And you're more than welcome to do that by hand if you feel the need to. And page 632 goes on how to do it by hand for like a 3x3 matrix. And you are more than welcome to do that as well. Whew. I just want you to do these in a calculator. And if you feel like you need another example, I would go back and watch this again. Now that you've done it once, go back and again and watch it. It'll help because you know this is recorded. But also you can easily find this more materials on like YouTube on how to find an inverse matrix in a TI-84 calculator, TI-83, whatever you have. It will be on YouTube. You're not the first group of college algebra students to do this by any means. So for homework in 6.4, it starts on page 639. And it goes from 1 through yeah, you don't have to do that part. 13 I just want you to do 13 through 27 odd. It's not a lot, but it's just finding the inverse matrix. Yeah, 13 through 27. But all I want you to do is find the inverse matrix. That's it. Okay. Your book kind of goes into how to do it by hand, even in the question description. I just want you to find the inverse matrix. Okay. So, hey, guys, this is the last lecture for college algebra. Yay, we made it. So, for the next lecture, we're just going to review. Actually, for this class, you've got, I believe, 2 more lectures. So, we're going to review the next 2 lectures. So I want you to send me questions. It's going to be a very unstructured review. It's going to be based on your questions. Okay. So based on your questions, send me any questions you might have from previous tests, from these last 3 sections we've covered that haven't been on a regular test. Or you can come to class at the class time and I can go over it. Either way is fine. So if you have any questions, comments, or concerns, please let me know. And I'm going to stop the recording.